Okay, you're welcome to this class. Here we are going to be looking at work energy and power. Okay, work energy and power. So much to learn here. Um, Here we see that the work done by a force is defined to be the product of the component of the force in the direction of the displacement and the magnitude of this displacement. So you see that work is actually F dot S, dot product of force and displacement, which is Fs cos theta. Fs cos theta. Okay, that means force times displacement then times cos theta. Now let's note something here. If a horizontal force is applied, you know, then cos theta will be 1. Let me give you an illustration here. Let's say we have this. And the force we applied is a horizontal force. So it means that there is no angle. Initially, when it is at an angle like this and you have this, okay, there is an angle theta. This is your applied force F. Just here, your applied force is F. So in this second case here, that is where work is Fs cos theta. Okay, force times distance cos theta. But in the other case here, your cos theta is 1. Cos theta is 1. Why? Because it is horizontal. Because there is no angle. Cos 0 is equal to 1. Since here, it does not make any angle with the horizontal. So please, let's note that. Okay, now let's see a question quickly. An object is horizontally dragged across the surface by a 100 Newton force acting parallel to the surface. That's horizontal. Okay, it's parallel to the surface. Find out how much work done by the force in moving an object through a distance of 8 meters. This is quite easy because work here is simply force times distance, cos is parallel, so cos theta is 1. So the force here we're given is 100 newtons. The distance here is 8, so that's going to give us 800 joules. The unit of work is in joules, okay? You can see that here that the unit of work is joules, okay? So let's see another question. It says a bee traveling on a straight line wire is brought to rest at 0.2 meters by friction. So the force acting here is frictional force that brings it to rest 0.2 meters. If the mass of the bead is 0.01 kilogram and the coefficient of friction between the bead and the wire is 0.1, determine the work done by friction. Work does not change formula. In this case, still, the wire is parallel, is horizontal. There is no angle here. So it's still force times distance. But the force here is frictional force. And what is frictional force? Frictional force is mu mg. Watch my video on friction. So frictional force is mu mg. Mu there is coefficient of friction. M there is mass. G there is acceleration due to gravity. Of course, everything here will be multiplied by the distance s. So if we substitute value, your coefficient of friction mu is 0.1. 0.1 now, multiplied by the mass m is 0.01, then multiplied by acceleration due to gravity, we're using 10, then your distance s is 0.2, so we have 0.2. Now if we, let me quickly use my calculator here. Times 10 times 0.2, we are going to be getting 0.02. So the answer here is 0.002 joules, which of course means 2 times 10 raised to power minus 3 joules. So the answer here is B. Beautiful. Okay, so let's move to another question. It says a boy drags a bag of rice along a smooth horizontal floor with a force of 2 newtons applied at an angle of 60 degrees to the floor. You see here, the force is applied at an angle of 60 degrees to the floor. The work done after a distance of 3 meters is, here we're going to use my work to be Fs cos theta because there's an angle here. So this will now be equal to your F, which is the force is 2. Your distance here is 3 meters, then cos theta, that means cos 60. And that the answer is going to give us 3 joules if you use calculator because cos 60 is 0.5. So the answer here is A. This is beautiful. This is beautiful. Okay. So look at this. It says in the figure above, the work done by the force of 100 newtons inclined by an angle of 60 degrees to the object dragged horizontally to a distance of 8 meters is, there's an angle here, so your work as usual is equal to Fs cos theta. So your F here is 100, your distance here is 8, then cos 60. Okay, so this is going to give us 400 joules. So D here is the answer. Now this says a constant force of 40 newtons acting on a body initially at rest gives an acceleration of 0.1 meter per second square for 4 seconds. Okay, calculate the work done by the force. Calculate the work done by the force. Okay, here we are given acceleration, and work, the formula still remains the same, Fs cos theta, but the problem here is we are given acceleration, we are given time. We can use the equation of motion to find the distance, because we can say S is equal to ut, this is the best formula to use, plus half at squared. Okay, I'm using the equation of motion. So my S here will be equal to your u, initial velocity is 0 because it says the body is initially at rest. The time here is 4 seconds, then plus half times your acceleration is 0.1. Okay, then multiply by your t is 4, so 4 squared. So by the time you use your calculator, 0.4 here is 0, so we are going to have 4 squared, 4 squared times 0.1 divided by 2. So that means my distance here is 0.8 meters. 0.8 meters. So since the work done is Fs cos theta as usual, okay, just Fs here, there is no angle here. So my force here is 40, multiplied by S, which is the distance, is 0.8. And if we do that, we are going to get 32 newtons. So that's the answer to that. I mean 32 joules, sorry. Joules is the unit of work. Beautiful. Okay, so we see another question here. It's going to be question galore. It says a body of mass 40 kg is being dragged along the floor by a rope inclined at 60 degrees to the horizontal. So the rope is inclined at 60 degrees to the horizontal. The frictional force between the block box and the floor is 100 newtons, and the tension on the rope is 300 newtons. So here there is a resultant force. How much work is done by dragging the box with a distance of 4 meters? If I need to draw this in a diagram, this is what it looks like. The force here acting at an angle, the force is 300 newtons, and is acting at an angle of 60 degrees based on the question. And there's a frictional force. Remember, frictional force is always opposing motion, that's 100 newtons. So in this case, we must find the resultant force. What is the resultant force? If you have watched my video on resolution of forces, the resultant force will be 300 cos 60 minus 100. 300 cos 60 minus 100. Okay, so if we use our calculator here, it's going to give us 50 newtons. Resultant force is 50 newtons. So we can now say that our work done here, our work here will now be equal to force times distance. So the resultant force times the distance, which is going to be, the resultant force is 50, the distance is 4, so that's going to give us 200 joules. So that is how you answer a question like this. Okay, this is very, very important. Beautiful. Okay, so we see the next. Here it says calculate the work done in carrying a box of mass 5 kg through a height of 10 meters. Now in this case, now the work done is potential energy. Work done still does not change its force times distance, but in this case now the force here is the force of gravity because it is moving to a height. So force is force of gravity, which is mg, mass times acceleration due to gravity. Then you have your s. So work done here is mgs. So the mass is 5, as acceleration due to gravity is 10. The height, which is s now, the distance is also 10. So that is going to give us 500 joules. Okay, so that is what we do here. Now that leads us to energy. Okay, so let's see. Now energy is the ability to perform work, the ability to do work. And energy can neither be created nor destroyed, and it can only be transformed from one form to another. You should know that that's according to the law of conservation of energy. Okay, now the next is that the unit of energy is the same as that of work. Okay, which is joules. Please note that energy is found in many things, and thus there are different forms of energy. Different forms. Okay, all the forms of energy are either kinetic or potential. All of them can either fall under the category of kinetic or potential. Okay, we are going to be explaining that. Now, energy in motion, as long as the energy is in motion, is a kinetic energy. It is known as kinetic energy, whereas potential energy is the energy stored. I also call that rest energy, okay, in an object, and it is measured by the amount of work done. Okay, so you can see, so work done can be potential energy. Work done can also be what? Kinetic energy. They have the same unit, which is in joules. Okay, now let's see different forms of energy here. Some other types of energy are given below. We have mechanical energy, we have mechanical wave energy, we have chemical energy, electrical energy, magnetic energy, radiant energy, nuclear energy, ionization energy, elastic energy, gravitational energy, thermal energy, heat energy, and so on and so forth. Now let's look at kinetic energy. Kinetic energy is the energy in motion. Okay, when an object is in motion, is the energy when an object is in motion. And okay, and the energy in motion is known as kinetic energy. For example, a moving ball, flowing water, anything moving has an energy, and that energy is kinetic energy. So kinetic energy is half mv squared, where m is the mass of the object, v is the velocity of the object. Now let's look at potential energy here. Potential energy is this is the energy stored in an object, okay, and it is measured by the amount of work done. Okay, it's measured by the amount of work done. For example, pen on a table has a potential energy. Water in a lake has a potential energy. So potential energy is simply mgh. My sitting down doing nothing, potential energy. You have potential to do work even though you're not doing any work. It's your rest position. Okay, your m is the mass of the object in kilograms, your g is the acceleration due to gravity, and while your h is height in meters. Now what is mechanical energy? Mechanical energy is the sum of potential energy and kinetic energy, just like we've seen before. So potential energy, which is mgh, kinetic energy is mv squared. So please let's note that. Now let's look at the law of conservation of energy. Here the law of conservation of energy states that energy can neither be created nor destroyed, although it may be transformed from one form to what? Another. And here, let's consider a stone falling from a height. As potential energy is being lost, kinetic energy is being gained. Okay, look at this stone here at this height. So as it's falling down, when a stone is falling down, it is losing potential energy because it's reducing in height. But that falling, because it is moving, it means that the potential energy is gradually being converted to kinetic energy. That's why we see here at the maximum potential energy, total energy is the potential maximum potential energy, which is mgh. But as it is falling at this particular height here, hx, you see that the total energy is a combination of kinetic, because in the middle of the motion, it has some potential energy and also has some kinetic energy. So that's why we say mghx plus half mv x squared. But when the object is about to hit the ground, at this point now it is about to hit the ground, in that case here, the kinetic energy is maximum. There, the potential energy is zero because it already is on the floor. The height is zero. Okay, so the total energy ET is half mv squared. And I want to let you know that according to conservation of energy, all the energies are equal. That means mgh is equal to mghx plus half mv x squared, which is also equal to half mv squared. And that is exactly what I just posted. mgh is equal to mghx plus half mvx squared, then plus half, equal to half mv squared. Note that. So the total energy at any point is the same. That's conservation of energy. Energy is not created. Any energy that is lost will be gained in another form of energy. So as you are losing potential energy, you are gaining it in kinetic energy. As you are losing kinetic energy, you are gaining it in potential energy. Energy is never lost. So the total energy at point A, the first position, is equal to the total energy at the second position, equal to the total energy at the final position. Beautiful. Now let's see questions here. Here says a stone of mass 2.0 kilogram is thrown vertically upward, that means potential energy, with a velocity of 20 meters per second. Calculate the initial kinetic energy of the stone. Here we are given mass, okay, we are given velocity also. So the kinetic energy, we know that kinetic energy, since we are given mass and velocity, kinetic energy will be equal to half mv squared. So that will be half times, the mass is 2, the velocity is 20 squared. So that will give us 400 joules. I think this is quite easy. This is the answer here. So let's see another question. A body of mass 20 grams projected vertically upwards in a vacuum returns to its to the point of projection after 1.2 seconds. That means it went up and came down. Went up and came down. Determine the potential energy of the body at the maximum height of the motion. Now, anytime you see a question where an object goes up and also comes down, know that the total time, they said it takes 1.2 seconds to return. So that means the time it takes to go up is 0.6 seconds, and the time it takes to come down is 0.6 seconds. That's, you divide the total time by 2, meaning it takes 0.6 seconds to go up and it takes 0.6 seconds to come down. Please don't note that. Note that. Okay, and here we are asked to find the maximum height of this motion. Okay, they said determine the potential energy at the maximum height. So this is the maximum height here. Potential energy in this case here, we can say is mgh, but we need to know what the maximum height is. We can find maximum height from the formula. If you remember your equations of motion, we are not given the velocity. Okay, we can find maximum height using the formula. There are two ways I can solve this. I'm going to use this method first. Let's see if we can find height. We can say that here S is equal to the height. I'm looking for the best formula to use. Upward motion. Okay, let's use the downward motion here. We can say that S is equal to half at squared. Okay, acceleration, or half gt squared. That will work. Beautiful. Half gt squared, or ut plus half gt squared, because in a downward motion, remember that u is equal to 0, so your u is 0. Okay, so half gt squared, so that will be half times your g is 10, then your t is 0.6, so we have 0.6 squared. So by the time we multiply that, let me do that quickly here. 10 times 0.6 squared divided by 2, that will give us 1.8. So this is 1.8 meters. So now that we've gotten 1.8 meters, we can find the potential energy, mgh. Your m here is 20 kilograms, which is 0.02 kilograms when you convert it. G is acceleration due to gravity, that will give us G10. Then h is the height, which we just calculated to be 1.8. So if we do this, we are going to get 0.02 multiplied by 10 multiplied by 1.8. We're going to get 0.36. So this is going to give us 0.36 joules. Okay, so the answer to this question is what? Is A. Now, but I said there's something else we can do here. We can also, let me rub this off. We can also find the velocity of throw, because potential energy, maximum potential energy is the same thing as maximum kinetic energy. So let's see, what is the energy of throw? Since we are given time, your u, t is supposed to be u over g according to the equations of motion, upward and downward motion. T is u over g. So since the t, time to reach the maximum height is 0.6, time to reach maximum height is 0.6, equal to u all over your g. Your g is 10, so that means your u will be equal to 0.6 times 10 by cross multiplication will give us 6 meters per second square. So in this case, we can use kinetic energy. Kinetic energy is equal to half mv squared or mu squared, which is half times your u is 0.02. I mean your mass. Then your u is 6, so we have 6 squared. So by the time we are done, we are going to get 0.36 joules. You see the same answer. This confirms that the maximum potential energy is the same thing as the maximum kinetic energy. Very, very important. Now we see a question here. It says a body of mass 4 kg is acted on by a constant force of 12 newtons for 3 seconds. The kinetic energy gained by the body at the end of the time is, our kinetic energy is half mv squared. Okay, I can solve this question in many ways, but let's see. We are given force. I know our kinetic energy is supposed to be half mv squared, so my mass is given here, which is 4 kg, but the problem is velocity. Now, but since we are given force, we can find velocity. Let's see. Force is also mass times acceleration, if you can remember. So acceleration here will be force over mass. So the force here is 12 newtons. The mass is 4. So that will give me 3 meters per second square. And since we are given time, seconds to be 3, we can find velocity. Since the velocity is a constant force, so what is velocity? Or put it this way, acceleration is supposed to be velocity all over time. If you remember equations of motion, that means velocity is equal to acceleration times time. So acceleration is 3, time is also 3, so that will give us 9 meters per second. You see, one needs to be dynamic. Now that we found velocity, we can now find the kinetic energy, which is half times the mass is 4 times the velocity is 9, so 9 squared. So that will give me 2 times 81, that's 162. So the answer is B, 162 joules, 162 joules. This is beautiful, beautiful. Okay, so let's see another question here. It says a carpenter on top of a roof of 20 meters high dropped a hammer of mass 1.5. Remember, being on top of a roof, it has a potential energy. Drop a hammer of mass 1.5 kilogram and it fell directly to the ground. Its kinetic energy of the hammer just before hitting the ground is, in this case, kinetic energy, because just before hitting the ground is maximum kinetic energy. And remember, maximum kinetic energy is equal to maximum potential energy according to the law of conservation of energy. So here we can easily find potential energy because potential energy is mgh. So your m here, your mass here is 1.5, your g is 10, of course, and your height is 20. Okay, so if we use, we are going to get 300. So the answer is 300 joules. As simple as ABC. Okay, so see another question. I'm solving as many questions as possible, so that we can have a perfect understanding of this topic. Now here it says an object is moving with a velocity of 5 meters per second. At what height must a similar body be situated to have a potential energy equal to the value of the kinetic energy? At what height? And this guy is moving with a velocity of 5 meters per second. This question is crazy. Now, so since we are looking for a height where the potential energy and the kinetic energy are equal, what it means is that I can find the total energy. The total energy here is the total kinetic energy, which is half mv squared, because we are given the velocity, the initial throw. Okay, so that will be equal to, oh, we are not given mass, so that cannot solve this question. This cannot solve this question. So let me look for another method. Here, since potential energy is equal to kinetic energy, we can say that mgh is equal to half mv squared. Okay, so m cancels m. That means your h now will be equal to v squared over 2g by cross multiplication. So your v is 5, so 5 squared all over 2 times 10. That will be 25 divided by 20. This is 25 divided by 2 times g. That's 20. That will give us 1.25. So the answer is 1.25 meters, so which is C. Okay, so if the potential energy equal to kinetic energy, that is exactly what we do. Now look at this. It says an object of mass 100 grams projected vertically upwards from the ground level has a velocity of 20 meters per second at a height of 10 meters. The velocity is 20 meters per second at a height of 10 meters. So that means there is still part of the motion is potential, part is kinetic. Calculate the initial kinetic energy at the ground level. The initial kinetic energy at the ground level is the total energy. Don't forget. So let's see. And what is total energy? So we are going to find mgh. We're going to find mgh. Mgh, your m mass is 100 grams. That means 0.1 kilogram. Multiply by 10. Then multiply by the height. The height is 10 also. So here is going to give us 10 joules. So potential energy is 10 joules. What is the kinetic energy at this same height? Is half mv squared. Okay, that means half times your mass is 0.1 and your velocity is 20, so 20 squared. So that's going to give us 400 divided by 2, 200 times 0.1, 20 joules, you see. But that's not what we are asked to find, you see. And amazingly, 10 and 20 are in the options, but none of them is the correct answer. They say we should find the initial kinetic energy of the ground level. The initial kinetic energy of the ground level is the maximum kinetic energy, so which is also equal to the potential energy at that height plus the kinetic energy at that height, which is 10 plus 20. That will give us 30 joules. 30 joules is the answer. This is beautiful. This is beautiful. Okay, let's move on. Now here we are given an object of mass 0.25 kilogram moves at a height of h above the ground with a speed of 4 meters per second. If the mechanical energy at this height is 12 joules, remember what mechanical energy is, the total of potential and kinetic is 12 joules. Determine the value of h. Okay, it's quite simple, the same thing we've done. So let's see, what is mgh? First of all, your m here is 0.25, your g is 10, and your h, the height, is what we are looking for. So that will give us 2.5 h. Okay, then let's see, kinetic energy is half mv squared. So that will be half times your m, of course, is 0.25, then times your velocity. What is the velocity? Velocity is 4, so we have 4 squared. So let's see, 0.25 times 4 squared divided by 2. So that is giving us 2. So the answer here is 2. Okay, so 2 joules. Now the sum total, 2.5h, that's the potential energy, plus 2, which is the kinetic energy, is equal to the mechanical energy, which is 12. So 2.5h, sorry, 2.5h is equal to 12 minus 2, which is 10. Okay, that means h now will now be 10 divided by 2.5. 10 divided by 2.5, that is going to give me 4 meters. Okay, so 4 meters. This is beautiful. This is beautiful. Okay, let's continue. We'll move to the next stage, power. What is power? Power is the time rate of doing work. So, meaning that power is equal to work done over time. And but power, work done is also force times velocity. I mean force times distance. So power can be force times distance over time. But remember that distance over time is velocity. So work is force times velocity. I mean power is force times velocity. So we can either use this formula, work done over time, or force times velocity. Don't forget that. So we'll go into a question straight. Yes, that is not a problem. Yeah, it says a car of mass 800 kilogram attains a speed of 25 meter per second in 20 seconds. The power developed in the engine is the mass of the car is 80 kilogram, attains a speed of 20 meter per second in 20 seconds. Find the power developed in the engine. Here, the best formula to use here would be power is equal to force times velocity. That will be the best formula to use here. Or I can say work is also energy over time. Anyone I use is good because I can see that since it has a velocity, we can find the kinetic energy, which is half mv squared. Okay, then all over time. So that means I can say half times your m is 800 times. Remember that work is also energy. So your speed v is 25. So we have 25 squared. Now divided by the time is 20 seconds. So if we do that, you're going to get, I'm on my calculator here. Divided by 20. So that will give us 12500. 12500 joules, which is 1.25 times 10 to the power 4 joules. Okay, so the answer is A. That's beautiful. That's beautiful. But I would like to also say this, that you can also solve this formula using work done over time. Okay, that's what we did. You can use the formula using force times power is force times velocity. P equal to Fv. Here now, the force can be mass times acceleration. So we say mass times acceleration, then times velocity. How do you find acceleration? Since you are given velocity here, you can find acceleration. You're given velocity, you are given time. You can find acceleration because v is equal to, velocity is equal to acceleration times time. So acceleration now, A will be equal to v over t. This is beautiful. Okay, and by the time you substitute it, you should be able to find power and you will get the same answer. But with what I've shown you, I think that's the best way to go about this. Since there's speed, velocity, you can find what is it called now? You can find kinetic energy, then divide it by time. That's the best way to solve that question. Now, if a cage containing a truck of coal weighing 750 kilograms is raised to a height, that's potential energy, of 90 meters in a minute, the total power extended, in this case here, my power is going to be, the energy here is mgh, that's the work, is potential energy, then all over time. Okay, so that will give you, that will be 750 times g is 10, h is 90. The time here is 1 minute. 1 minute means 60 seconds. So let's see, we're going to have 750 times 10 times 90, then divided by 60. That's giving us 11250 watts, which means 11.25 kilowatts. So the answer here is C. Beautiful. Okay, and here it says a body is pulled over at a distance of 500 meters by a force of 20 newtons. A body is pulled over a distance of 500 meters by a force of 20 newtons. If the power developed is 0.4 kilowatts, if the power developed is 0.4 kilowatts, calculate the time interval during which the force is applied. Calculate the time interval during which the force is applied. Okay, now since power is work done over time, the power here, we are given power here to be 0.4 kilowatts, And 0.4 kilowatts here multiplied by 1000 means 400 watts. Okay, and it's pulled over a distance of 500 meters. So I can find work here. Work is simply force times distance here, since a force is given and distance is given. Okay, so the force here is 20 and the distance is 500. So that will give us 10,000 joules. Okay, and we know that power is work over time. So since we are looking for time, time will now be work over power. That means 10,000 divided by 400. That will give us 25 seconds. So the answer to this question is C. Okay, now this is the end of the video, but I want to note certain things here quickly in this video. Let me rub this off. Just few things to note. Okay, now there's power can also be mass flow rate. Let me call it MT. In case they give you mass flow rate, the unit of flow rate is kilogram per second. That means they've sorted out the issue of second. Mass flow rate times acceleration due to gravity times time. So you use this formula especially when you are given that a liquid is flowing, and maybe a liquid is flowing at 20 kilograms per second. That's flow rate. You know, in this case here, you can just say power is the mass flow rate times acceleration due to gravity, then times the height where it is dropping. Note that. That's very important. Now, another thing I want you to note in this video is efficiency of a machine. Maybe a machine is pumping water to a height and all that, and you're asked to find the efficiency. Now, the efficiency of that machine is going to be what we call work output all over work input multiplied by 100%. Or you can say power output out all over power input. Okay, multiplied by 100%. Now, you might ask in a question, how do you know power output and power input? Your work output, let me use work for example. Your work output is the energy you expended in getting the work done, like potential energy mgh, kinetic energy m half mv squared. Work input will usually be given. Work input or power input is the capacity of the engine in which you are using to do the work. Like when they say this generator is 20 kV or 20 kilowatt generator, that's the power out input, because that's the capacity of the machine or the capacity of the generation you are using to do the work. But output means the work that was actually done, which is you can get by using any of the formulas that we are given. Thank you very, very much. See you in another class.